Okay, so in terms of reaction mechanisms, two conditions have to be met for a potential mechanism to be valid. First off, the mechanism steps have to add up to the overall reaction. So let's take a look at how that works. So we had three possible steps involved in the suggestion for this overall reaction. So kind of like Hess's law, kind of like what we did with the equilibrium reactions. You have to add up all the reactants, add up all the products, cancel out any common things on both sides. So I've got NO, NO going in, and it produces an N2O. Okay, but immediately N2O goes back in. So it gets produced and then it disappears. So N2O is actually going to cancel out. It is referred to as an intermediate. It gets created, but it gets used up further on down the mechanism. So in the overall reaction, you don't see it appear. So NO and NO, two reactants. H2 now becomes another reactant. And what are we going to produce? We're going to produce N2O and H2O. Okay, so far we have three reactants and two products. But H2O is a product. You don't see N2O here. So in the third step, N2O actually is going to get used up. So N2O is another example of an intermediate. It's going to react with another molecule of hydrogen. So two H2s, there it is. Two NOs, there they are. These guys aren't reactants, they're intermediates. They were made, but then we used them up. And what do I make in this third step? Nitrogen gas, there it is, and another water. I had one water here, I have a second water here, two H2Os. So the product of the first step is an intermediate. One of the products of the second step is an intermediate. They cancel. What am I left with? The overall reaction. So this mechanism is a valid possibility for how the reaction takes place. Excuse me. The second thing that all reaction mechanisms have to have is that the slow step has to match what the rate law step is. So going back to that reaction, if we take a look at what the slow step is, the slow step is N2O2 plus H2 yields N2O plus H2O. So we want H2 definitely to be in the mechanism or the rate law, but N2O2 is an intermediate. So if you think about what we did the last time, we took N2O and actually made it represented by NO squared. So we have two NOs and an H2. So that supports the mechanism that we proposed, or that supports the rate law that was proposed for that reaction. Okay? So we've got this being the rate of the slow step, but N2O can't be part of the overall reaction because it's an intermediate. So we have to go back and do that same thing we did before. The N2O2 has to be replaced with the two NOs, or NO squared. So then, since this guy is equal to the NO squared, we've got a rate that is NO squared times H2. It supports the second step being the slow step. The first step is a faster step, so it supports the mechanism that we've come up with. All right, so an intermediate is a substance that's formed and then gets used up during the course of the reaction. It doesn't appear in the overall reaction. We already identified the intermediates, kind of did that a little backwards. We know that this is an intermediate and this is an intermediate. All right, so here's another example of one. What's the overall reaction going to be? What's a catalyst? A catalyst is something that doesn't, over the course of the reaction, doesn't get used up. So it goes in, helps the reaction happen, but in the end, it's still there. Identify any intermediates and write the overall rate law. So take a minute, pause the video, give yourself a chance to try all that. All right, so overall, we've got, let's identify, the overall reaction is going to be this because we've got 2 Ce4 pluses going in, nothing coming out. We've got a Tl plus going in. We have, on the product side, we have created a Tl3 plus. That can't cancel out. And we have 2 Ce3 pluses. So that's our overall reaction. What about everything else? Okay, we got some intermediates. Ag2 plus is created here, but then it's used up further on down. That's a intermediate. Tl2 plus, again, created in the second step, but used up in the third step. So again, an intermediate. The only other thing we have is Ag plus. Ag plus goes in first and then comes out later. That's actually the catalyst. So intermediates first appear on the product side, disappear, get used up further on down as a reactant. Catalysts go into the reaction first. They start out as a reactant, but in the end, they come back out. So that's how you can tell the difference. The rate is going to be, since it's the slow step for number 2, we've got Tl plus. Ag2 plus is an intermediate, right? It gets generated and then used up, so it's not really a reactant. So we're going to take this Ag2 plus and make it be represented by where it got made, so the Ag plus and the Ce4 plus. So notice that we've got the concentration of these 3 things affecting the rate. And even though Ag plus is a catalyst, we can measure its concentration. We have it at the start of the reaction, so we can have its concentration. It can contribute to the rate, which we need it to. And so the rate law overall is going to be a combination of the first and the second steps. That's basically what you need to think about. What are the reactants of the first and second steps going in? And in this case, the catalyst. Okay, last idea. Catalysts are going to change a mechanism by the way that the whole process occurs. So for example, why is this happening? The catalyst is going to increase the rate of the reaction by decreasing the activation energy. So here's the typical uncatalyzed reaction. But if you look at what a catalyst does, it offers an alternative pathway. It gives you the opportunity to have this reaction happen a little bit differently. And so as a result, look what happens. The reaction happens by a different pathway, but the activation energy is a little bit lower. So it changes the entire mechanism by which the reaction occurs. Some catalysts can speed up the rate of a reaction simply by allowing the components to be oriented in the right direction. So that's the way enzymes actually work. They make sure that the molecules come in, they're oriented in the right way, so that then they can collide properly with the right orientation, and you get a product out. So again, you've seen enzymes work like catalysts in the body. You have the substrate that comes in, sits into the enzyme. You get the enzyme substrate complex, and then the enzyme causes the products to be created. There's a little bit more in the textbook to read about enzymes. I haven't covered in this. It's pretty straightforward. The big ideas, focus on the big ideas. But that is the end of the information at this point.